me see if it's actually recording. So here we go, math 2. Move this out of the way. And need to turn you down. So what's it mean to be tangent? What do we know? So we're talking today about tangent lines in circles. But what does it actually mean to be tangent? Jacob?
It means that if a line is tangent to a circle, it means that it touches the circle exactly once.
Yeah, so does it pass through the circle?
No.
No. But it makes contact with the circle, right? So if it only just makes contact, oh, you told us about this. Thank you. If it only makes contact, okay, so now you guys are curious. It's a book called Teach Like a Pirate.
It means you like get a hook hand and a sword and say R a lot. Like, Arr!
Arr!
We're gonna learn exponents today, mateys.
You swab the poop deck and you make people walk the plank, right? So if it touches exactly in one point, so this is each ray from point A touches the circle in only one place, no matter how far it extends. Measure AB and AC. Repeat the procedure with a point further away from the circle. What about any two rays? So if B is our tangent point and C is a tangent point, then we kind of make like a triangle here. We at least make an angle. So we have angle A. So think about what would happen if we measured those. If we then put point D further away, still it's tangent. It only touches in one location. What do you see now? It's added some notation. What about AB and AC? What do you now see? Robert?
That they're congruent.
They're congruent to each other. DE and DF are congruent to each other. Any point that lies outside the circle with two lines tangent to the circle, so there will obviously be two different tangent points, the distance of those lines, of those segments between the outlying point and the tangent points are going to be congruent. So it's a really cool relationship that we set up here to be able to see that all those distances are congruent. And what's more than that is it's perpendicular to your radii, to the radius at that tangent point. So the radius that goes from the center to B, that is now perpendicular to AB. The radius that goes from the center to E is perpendicular to DE, and so on for all the other points. Any questions about that?
No.
How do we use this? What's it useful for? Like those sorts of questions?
Yes.
Yeah, so those, yeah. But any like direct questions right now?
Can you like rephrase the thing that you said? I'm just really confused.
So let's talk only about my outlying point D for the moment. The distance from D to its tangent point, which has to be a point on the circle that the line touches just once, it like just barely touches it, that distance is going to be congruent to the any other tangent point. Now there's only going to be one other because we're coming from that fixed location D. So you can only come from there to find one tangent point up on the top and one tangent point on the bottom, but the distance between those lines, like the distance between D to B and D to E and D to F are going to be congruent. It'll be easier, especially once the blue backdrop goes away. Jacob?
What's the maximum what's the maximum amount of degrees that you can have, like, for angle D? Because it can't be 180.
Ooh, we're going to get there. That's a good question. We will get there, though.
21.
So think about it. If you're going to be tangent and you're going to be perpendicular to a radii at each tangent point you touch, and there's only going to be able to be two tangent points. So like before we even go through these, if we're just like, because Jacob asked the question, we're just hypothesizing this. To get a bigger angle, you got to get closer and closer and closer and closer, because the further away you are, the more acute your angle is going to be. So if I had a point down here, I'd have a line that was tangent up there, a line that was tangent over there. This radii is going to make a right angle. This radii is going to make a right angle.
So you can make a square.
So keep that idea in your head of what would be that biggest angle on the outside. Not disagreeing, just thinking about it. So here's our Theorem 76. Line is tangent to the circle, then it touches exactly at 1 point, and AB is perpendicular to OP, your tangent line, perpendicular to your radius. If a line touching your circle once is perpendicular to your radius, then it must be a tangent line. So just kind of the converse of that theorem. Well, capturing would be useful. Capture. And then our perpendicular lines. So from the same outlying point, so like point B, distance from B to A and distance from B to C, with A and C being tangent points, will be congruent. Cool? Let's apply this. So now I'm going to find unknown angle measures.
In this problem, you will find the measures of angles formed by tangents to a circle. Segment ML and segment MN are tangent to circle O.
We also know if
What is the value of x? Your answer choices are A, 58, B, 63, C, 90, and D, 117.
Really have here, because there's something else I can label that would, like, as soon as we label that, you're going to know what the shape is. Emily? Huh? Why would it be a kite? What else do we know about this? It looks like a kite. Cal? Or
Two of the sides are radii, and that means that they're equal.
two of the sides are radii, and that means that they're, now again in geometry we say congruent instead of equal. So these are congruent to each other, and since we have two pairs of congruent sides and they're next to each other, they're adjacent, this is a kite. What else do we know about a kite? Robert?
Or if you have make diagonal lines perpendicular.
Diagonal lines would be perpendicular. There's also one of our tangent theorems that is really useful here. Jacob?
The two opposite sides are, the two opposite angles are like congruent.
Like 117 and x?
No, like the other two.
The other, why? What theorem? Like, you don't have to know theorem number, but why? Like, what? Okay, so they're congruent with each other, but what else? They're congruent and they're perpendicular. We know that since these are tangent lines, angle L is actually a right angle. Angle N is actually a right angle. So I now know 3 of my 4 angles. We can solve now. So we know that the combined angles inside of a quadrilateral is 360. So I add up my 90, and my 117. I remove that from 360, and we get
63.
Yes, x will be 63 degrees.
So if you have a kite, then you could just do 180 and then subtract whatever.
Well, be careful. Not every kite has the right angles there.
Well, yeah, but I'm saying
A kite with tangent lines.
with the tangent line,
Yes.
you just do that.
You don't need to worry about the other one.
And then if I show out their process.
Is this
Ba-da-da-da-da-da-da-bum-bum. Yeah,
Is this the whole like homework is gonna be like?
this is part 1.
I know, but like,
Oh
is it gonna be
shoot,
like
there's
this
a
basic?
part
Yeah,
2.
it's going to be similar to this.
Yeah, like different angle.
Yeah, it's going to just be applying our tangent lines and our relationships that we know about it. So try this on your own. Now you have a tangent line and a diameter, and then, so DE, I'm going to go ahead and call this point F. EF, we really don't know anything about, except, what kind of shape do we actually have here? More specifically, a right triangle, because I know that this angle must be a right angle. So solving for x is fairly easy, and if we had any of the lengths, we could solve, like if we had one length, we could use trig and solve our other lengths.
And the circle.
And what?
And we could also solve the circle.
We could solve the circle, because then we'd have the diameter once we knew the lengths, and from there we can solve the circumference and the area and all of that. But if we're just solving for x, Who's got my x? Yeah.
52.
52. So we do this a lot in surveyors. If you ever see the guys out there with like the things on the tripods and they're like looking through stuff and they got another guy like really far away. Surveyors use trigonometry and these sorts of rules all over the place because as you start to survey far distances, you have to work with the curve of the earth. Like it's not actually that far that you have to start to take into consideration the curve of the earth. Like when you're doing shooting sports, if you guys ever watch those like shows where they're like shooting crazy distances,
Yes.
when you shoot a certain distance, you have to adjust your sight for the fact that the earth is curved. When you look at a straight line, well, if you're going with the plane of the earth, it's actually a curve. Ben?
Does this go into the thing that I showed you?
I don't
I told
remember
you
what
that, like,
thing you showed me.
How is it that poster you have is on?
What?
With the triangle adding up to 0, all the angles adding up to 0.
What?
Maybe?
The triangles, the lines are like, because.
Tell me if you identify in the lesson like what you're talking about. How about that? So, CN Tower. I've been up here. I stood on the glass floor. It's kind of crazy. If you ever go to Toronto, check it out.
I've been there.
Yeah, so it's pretty cool. Toronto's not that far. Actually, you can get to Toronto in almost the same amount of time it would take you to like get to New York. So about how far is the observation deck from the horizon? So what they're saying is when you are up there in the tower and you look as far as you can see, well, you're really looking a line tangent to the earth, and the earth is round. So when you think about this, what we have, where, I don't know where the, I think maybe it's part of a solution and I just chopped it out. First thing you'd want to do is think about the earth and this tower. Now we're not going to be to scale, but on your paper I went ahead and gave you, there's a circle and we have the tower and we look at the distance up that we're viewing and then how far is it that we can actually see until we're tangent. So what we're wondering is this distance right here, we're trying to essentially solve like with a triangle in a way. So you're on your paper, it's a little better. I don't really want to show the whole solution. So 447 meters, we go ahead and we write as kilometers because we know how far you're going to be able to see is going to be lots and lots and lots of meters. So we convert it to kilometers. So they use 0.45 because it's approximately, and especially once you're up there, you add, a meter or two because you're, sorry, yes, good catch. Kilometers.
That's very short if it's 0.45 meters.
Yeah, right? Not a very good tower.
That's not a very tall observation deck.
Then we have to know a little bit of information. Earth's radius is about 6,400 kilometers.
Oh my God.
So, the distance here, 6,400, and or the distance here, if we have to use that,
Yes.
which we do. Because think about it, if you have a tower coming out of the earth, it's going to be in a straight line with the radius to the earth. It's like when you drill into the earth, you're going straight towards the radius unless they're specifically drilling at an angle. When you drill straight into a circle, you're going in a radius. So I'm going to go ahead and show a bit of the solution since their drawing is way better than mine. So you have that in your notes, the whole not to scale picture. We then just set up our Pythagorean theorem because we know both legs, we know the leg and the hypotenuse. What we don't know is one of our legs, ET, phone home. ET is one of our legs. The hypotenuse, how do we find the hypotenuse? Strawberry? Well, yeah, okay, if we didn't know it, but right now we can know the hypotenuse.
Oh, I know.
Emily?
You just gotta add the radius to how tall the thing is.
We just add the radius. So really, since the radius is 6,400 kilometers, the hypotenuse is 6,400.45 kilometers. So that's where we get this value right here is just this radius. Then we know our 6,400 is just the other leg. We solve the Pythagorean like we know how, and we end up getting about 76 kilometers. So when you view from up on top of the CN Tower, you can see about 64,000 meters, which if you want that in miles, sorry, 76,000 meters. I don't know where I started. 64 from the radius.
Wouldn't the answer technically just be 0.456?
No, I heard somebody say, wouldn't it be 7,600? Remember, kilo means thousand. So this is 76,000 meters. And then if you want to figure out how far that is in miles, you divide by 1,600 because there's 1,600 meters in a mile. Thank you to our runner. And it is approximately 47.5 miles. You can see over 47 miles from on top of the CN Tower.
Ooh, I could run from the scene.
How many feet are in a meter?
Between 3 and 4. I'd much rather use the meters to miles conversion because it's more accurate.
I'm just curious to see if the new World Trade Center is taller than this.
You can look up the direct conversion. It's like 3.2 or something like that feet in a meter. But that, like, you want more decimal places than that.
Okay, I think the Trade Center is taller.
Probably because when they were building it, they were like trying to be taller than things. All right, so try this. I want you to draw a sketch. We're on the back now. Now, on the horizon, gentlemen, stick with us. We are going to use the Earth's radius, but now we're going to use it in miles. So the Earth's radius is about 4,000 miles, approximately. Kind of crazy. So to drill all the way through the Earth would be 8,000 miles. So if we're drawing a sketch, distance to the horizon that a person can see on a clear day from an airplane 2 miles above the Earth. So I'm going to go ahead and come out this way and say this is 4,000 miles. Not to scale, here's 2 more miles. We want to see how far can they see. And this we're saying touches. Sometimes it's hard to draw tangent lines because it has to be very particular. And we also know this to be 4,000. So you have to determine what are you trying to solve. Well, remember, your right angle is where your tangent line meets your radius. So I have a leg and a hypotenuse. So we have 4,002 as my hypotenuse squared will equal my 4,000 squared plus, what do we want to label that? Sure, x, because x is our friend. I was going to do like v for like view or something like that, but x is always just pretty easy. And when we start computing these values, we're going to get really big numbers. So I'm going to go ahead and leave this work in my calculator. This is 1, 2, 3, 4, 16,004 for 4,002 squared. I'm going to subtract away 4,000 squared, and I end up with 16,004 being equal to my x squared. How do we evaluate this then? Square root.
It's going to be 4,000 approximately 127 miles.
That's what you got?
Approximately.
Yep. 126.5 miles. Or if you round, it'd be about 127 miles.
Ah, that triangle makes it look like it's a lot longer.
Not to scale. No drawing that you do of the Earth will ever be to scale. Actually, if you guys remind me someday, or if we have time at the end of class, I have a video about these guys went out in the desert to make a scale model of the solar system, because any picture you see of the solar system is not to scale. Like none of the planet sizes compared to each other never drawn to scale. The distances between them never correctly shown. Like any picture you find on the internet is not to scale because it takes such a big area and tiny dots for the planets to be a scale drawing.
Imagine this.
Yeah.
There's like one website
Yeah,
where you
just
like
to access
scroll
show
to the
this.
side.
Oh yeah, where
really
it's,
far and it
and they're pretty small still,
Yeah.
even though it's really far.
It's like most.
Yeah. So these guys, they took up a huge area of the desert, and they were still only able to show like 4 planets because they ran out of space and they ran out of time.
They like color it in.
They used lights. So they used like a pole with a light on it with a marble, or like a pole with a light on it with like something. And then they used like a big kind of like weather balloon as the sun in the middle.
It'd be
So-
terrible if they had to color all over.
Mr. Hudson?
Yeah.
If the Earth was like a tennis ball, how big would the sun be?
Big enough to hold one.
You can find the comparison. We can look it up later, but we got to keep getting through the lesson.
In this problem,
So we
you will
wanna
find the
now
radius
figure
of
out
a
the
circle.
radius. Now this becomes a
What is the
little
radius
more
of circle
difficult
C?
because now my hypotenuse is a sum. It's 8 plus x, or x plus 8, however you want to phrase it. Anyone got any ideas? Yeah, there you go.
It's 5.
Well, why?
Because 5, 12, 13 right
Yeah,
triangles.
that's
Because
Makes
what?
sense.
5, 12,
5,
13
12,
right
13.
triangles.
Is it one of those perfect
Yeah.
dilation things? But if you don't just know it, so let's take away the whole like stored knowledge. How would we compute it? Because like the got it, that's not as easy.
So it'd be like 8 plus x squared together in parentheses equals 12 squared plus x.
So now we're getting the squaring binomials. When we square the binomial, we gotta FOIL it. So, if you guys haven't seen FOIL yet, we're taking x plus 8 times itself. You may want to write down this process. FOIL literally means FOIL, but it's an acronym. Stands for you're going to multiply your firsts, your outsides, your insides, and your lasts. First, outside, inside, last. So, when I multiply my firsts, I get x squared. When I multiply my outsides, I get 8 times x, because x for this one and then 8 for that one, the outer terms. When I multiply my insides, I get 8x again, and that pretty much always happens, where we get the same 2 terms. And then we get 64. So what we really have is x squared plus 16x plus 64.
Oh my god.
Now that slow down or scroll down? Okay, I'm gonna highlight all these things to like make it obvious. My first takes my x with my x, gives me x squared. My outsides are my x and my 8x. Then my insides are my x and my 8, gives me 8x.
Excuse me, do you have staff?
Yes, ma'am.
Could he come to the office for an appointment, please?
He is packing up. He will be right down.
Thank you.
Thank you. And then your last takes your 8 and your 8, and you get 64. You cool, Emily? Cool. So, now because their writing is better and fits on the screen better, I'm going to whiz this through to show the rest of the solution. So we find out what our binomial squared is. We then have another x squared term over here, a constant term over there. And then I combine like terms, getting rid of my x squareds because now they cancel with each other. I get 16. Huh? Because BC was just the radius. So since I have an x squared on both sides, I subtract x squared from both sides and it disappears. And then I combine my constant values by subtracting 64 from both sides, and that's how I get my 80. And then I just do the math, and I solve and get 5. just like Jacob said.
That was a lot easier than it was.
Don't be afraid of squaring binomials. The more you do it, the easier it gets.
Well, must have a really good situation like this one.
Yeah, so now this one, not as perfect.
We're doing this by ourselves.
Yep.
I see how it is.
If you love something, let it go.
No.
Why, Mr. Hudson?
Okay, I was not at all referencing that horrible movie.
Yes.
But it's now happened, so I'm sorry.
Call it horrible. I apologize.
Okay, we'll let you slide since you called it horrible. He redeemed himself.
Here's the other trick that people do to square a binomial. And this may or may not help you. Square your first term. Square your second term. Then double your constant with the x. So 12x. That's if you don't want to walk through the FOIL process. Now if you walk through FOIL, first would be x squared. Outside would be the 6x. Inside would be the 6x. And the last would be your 36.
I think I figured this out.
Huh?
I think I.
First outside it. So if you put x plus 6, x plus 6. Firsts, outsides,
So why don't we use the 10?
insides, last. We do, but it's a leg. It's not the hypotenuse, it's a leg.
Oh,
This is
so FOIL
hypotenuse
FOIL
squared equals leg squared plus leg squared. I just like to put my hypotenuse first because it's...
FOIL, you only use the legs, the hypotenuse, no legs.
Yeah, FOIL only matters if we're squaring a binomial. Over here on the right side, we're squaring a monomial and we're squaring another monomial. One term. When you have to square two terms at the same time, it gets complicated. That's why we use FOIL. So, Leon? Yeah, so if I quickly show the rest of the process, my x squareds, and this is going to pretty much always happen when we have that the radius is x squared, they're going to cancel each other out because there's an x squared on both sides. I will subtract 36 from my 100, and that just gives me that 12x, what's 100 minus 36?
64.
64. And then when I divide that, what'd you get? What?
16 over 3.
Okay, so you're give it to me rationally first. 16 thirds, which approximately equals 5 1/3, or 5.3 repeating.
I get that.
I did it.
Now that, okay, easy is relative.
I said easier than trig.
Yeah, but so like in my mind, trig is really easy. My calculator does the work. You know what I mean? You think I'm special? Well, I know I'm special. My mom told me.
Oh my
That's
god.
I have that shirt.
See, I thought I'd seen one of you guys wear something like that.
Yeah.
Alex,
I just know.
All right, try.
Yeah, Alex Alexic is the one that wore that.
How do we test if something's tangent? So when it says is ML tangent, well, it looks like it's tangent.
We ask it.
Hey ML, are you tangent? Doesn't work.
Si, senor.
I mean, I know either of you are gonna know it. Jacob, I think I haven't talked to you in a little bit.
Okay, so what you do, since we can use the converse of the Pythagorean theorem to prove if it's a right triangle or not, and if it is a right angle, then it's tangent. So you can just do 25 squared. 7 squared plus 24 squared equals 25 squared. It's true.
I see what you did there, Cindy.
If tangent, there's going to be a right triangle because there's a 90-degree angle, and then MN would be like my hypotenuse here. But if so, this is a potential hypothetical. If tangent, that has to be a right angle. So test it with the Pythagorean. So what's 7 squared? Well, 49 plus 24 squared. That gets a little crazy. 576 that would have to be equal to 25. Yeah, 625. Sorry, that's one of our nice perfect squares. And if we check it, 576 plus 49, it is true. So this does, in fact, check out. It is tangent. Try the got it real fast. Those are easier, smaller, gentler numbers.
You mean they got it all the way at the bottom?
No. Middle of the page, right side, near your hole punch.
Okay.
We're in part 4. They got it.
Found it all by myself.
Wait.
What? Alright, so you sound confused. Talk it through, Ben. What is your first like square? Your smallest? Huh?
No, it's very.
Oh, yeah. Never mind. Sorry.
Will anyone talk me through?
I think I got this.
Carp, we haven't really talked yet today, so I was gonna.
So you do whatever we've been doing in the past one, like the. I forget the words. It's the actual.
Starts with a P.
Well, yes, Pythagorean Theorem.
Okay, that's all we have to do here, really, because
Yes.
we're checking
Don't we have to
is it
figure
a
out
right
what
triangle.
that little space is?
What do you mean?
We're not doing that.
8 is the whole length of NM.
Oh, that's the whole length?
Yeah, 8 is the entire length of NM.
Okay, they put it in. Okay.
So, take my leg squared, right?
E.
4 squared, 16 plus 7 squared,
That's
49.
I said
Does
50.
that
There's one
equal
off, Ben.
8 squared? What is 8 squared? 64.
No.
When I sum my left side,
65.
Senor,
not equal to
65 is not equal
64.
64.
So no, it is not tangent.
No, senor.
We actually could just look at the distributors.
No.
Yeah, but don't trust what you can only see. Trust what you know, don't just trust what you see. Alright, last part. So when we have circles inscribed into a triangle, my tangent rules are really, really useful.
In
And
this
why they're
problem,
really
you will
useful is
find
that
segment
first,
lengths using
you're
a circle
now
inscribed in a
problem
polygon.
where any
Circle O
tangent
is
lines
inscribed in
from the
triangle
same
A,
exterior point
B,
must
C.
be congruent.
What is the
So
perimeter
when I
of
see that
triangle
AB
A,
is 10
B,
centimeters,
C?
What else do I know? Emily? That what? Yeah, the AF must be 10 centimeters. Since I see that FC is 8 centimeters, then CE must be 8 centimeters. Since BD is 15 centimeters, then BE is 15, and I now know the entire lengths of my whole triangle.
And then you just add them up. I think. Wait, do you?
You really need that
Well, if
staple.
I'm trying to find the perimeter,
Yes,
yeah,
do.
you just add them up. So now that I know all that, I can just sum them, and we get 66.
This is one of the easier units.
This is.
Because like all your theorems help you out.
I like this.
As opposed to theorems that don't help you?
Yeah, like the trig theorem.
No, it's just that in some of them you have to think more than others. This
Right.
one is, like, using
Trig theorems
and it's
make
a
me
straight-
think.
it's a straight-
And the theorems are like very like kind of in your face.
Yeah, that's
Like
that-
the big thing is just remembering to apply the theorems.
yeah,
Because people will be sitting struggling with a problem, and then I'll just ask like, wait, what is this edge? And then it's kind of like the facepalm moment. So, Mackenzie, what's PZ? McKenna, what's XQ? Ooh. Mmm.
Hold up, what you do?
Do you know YR?
Why are you?
17.
Wire.
Wire. How do I figure out XQ and QY if I don't know either of them? Jacob?
Well, it tells you the perimeter, so you can set up XQ as X, and then you just do that 88 equals 30 plus.
Yeah, I'm going to go ahead and double when I have two terms the same. So I have 30, 17 doubled, 34, and then plus some x that I have 2 of. This gives me 64, so I can take 64 away from my 80.
24.
Yeah, it's 24, and then there's 4.
So then I get qy is 12 and xq is 12. Makes your life easy. The theorems actually help you. You know, I really like it when my theorems help.
Because usually they don't.
I mean, some of them are so not.
Huh? Even yours, your education.
All theorems are helpful.
All right, any other questions, comments, concerns?
You're going to be the one that's messed up in the head. Oh, wait. You're going to be the one who's messed up in the head.
All right, you guys can go ahead and start your homework. Please utilize this time.
I thought you said we were allowed to.
No.